All right. Good morning, everybody. Thank you guys for coming today. So we only have, I was just looking at the calendar, we only have 4 SI sessions left until the end of the semester. You guys are very much almost there. Next week, we will plan to do male and female reproductive. We may get to some male reproductive today. If we have time, I'm not really 100% sure that I want to do that just because I doubt you guys have watched the lecture yet. So it's probably going to be more helpful for me to do that next week. So probably Monday, I will do male and female reproductive. I can do them in one day. And then I can go over the models as well for male and female reproductive next week. Probably can do almost all of that in one SI session. So I'll probably plan for that on Monday's session. 4:45 to 6:45, we'll do that Monday. And then Thursday next week, 9 to 11, I would like to do a review session for you guys. And then the following Monday, probably also review. I'll plan for multiple review sessions so that way people can come in. So again, Monday next week, we're going to be doing reproductive. I'll probably be able to do almost all of it Monday. 4:45, I'll send out an announcement too. And then Thursday, we're going to do some lab review. I'll hope to start with muscles. And then the following Monday, I can also do more lab review because you guys have your test on Tuesday, the Tuesday right after this. Sorry, I don't have my dates, Monday the 8th. And then Thursday, I think Thursday's like, what would it be? 10th, 11th, maybe like the 12th. That day we will do some lecture review as well because you have your final the 16th, right? So that's kind of what it's looking like. The day of your final, I may hold an SI session for those who have questions about nursing stuff. And that way you guys could come. That would be like Monday, the 16th. If you guys had any nursing questions, I might do that. In the past, I've done that and students liked it. So it'd be like the evening after your final. You could just come on the Zoom session and then ask me a question. I'm going to share after your final a document for all of my nursing recommendations. And just like stuff that helped me in my nursing journey through my prerequisites and advice that I wish somebody had given me in like one synopsis form of a document. If there's anybody that wants it in advance, like before the day of your final and you really want to read it now, you're welcome to message me on Canvas, but I will share that with you guys after the final. It's just like my advice of like what classes to take next and like how to plan your classes to study for the T's. It includes like what I use to study for the T's, kind of questions I get about nursing school, where I applied to nursing school, how to apply to nursing school. It's all kind of in there in a summary form. I mean, it's like 3 pages long, so it covers everything. All right. Any questions this morning before we get started? If you haven't registered for your classes yet for fall, I mean, you're like planning on registering for those like now, I would recommend registering for physiology next. Again, this is for like nursing people, but I would recommend for registering for physiology next because physio is the one that coincides the most with anatomy, and I think that they go best back to back. So I would do physio next in the fall. I don't recommend physio over the summer. I did take it over the summer, and I just don't recommend it to other people. I think it's way too much. And then if you were going to do one over the summer, you could do micro over the summer. So if you guys have an opportunity to do microbiology this summer, I personally would take that opportunity and schedule your physiology for fall. As far as teachers for physiology, I took Lay, L-E, Lay, and I really liked his class because I feel like it prepared me really well for the information. It was very challenging. It was a challenging class, but I feel like it prepared me. And I've talked to other students that I recommended his class, and they said that they felt like that too, that they felt like his class prepared them. Other teachers that I've heard are good. There's a new teacher that I can't remember her name, but I think people said that they like her. And then Galileo people like a lot. So if you guys need advice on that, you're welcome to message me. You could stay today. You know, I'm here until 12. If you want to talk about any of that, that's totally fine. Okay, so last time we left off with the kidney, and we just wanted to talk about the 3 ways that the kidneys regulate blood pressure, right? That was our goal for today. And then what I'm going to do is I'm going to jump over to practice questions, and we'll go over the practice questions that I have in the module. And then if we want to do more, I might pause the session and write some more. Just kind of depending on what you guys want to do. So regulating blood pressure in the kidneys comes through the mechanism of reabsorbing salt and then allowing water to follow. So they're all going to kind of follow this process of reabsorbing salt and allowing water to follow. So the first one, so it's kind of like all dealing with salt follows water. Water follows salt. So the first one would be your countercurrent multiplier system. Countercurrent multiplier system. And this one is located in the loop of Henle, right? So this is the loop of Henle. That's where that one is taking place. And you have, remember, we have our little proximal convoluted tubule, and then our distal convoluted tubule, right? DCT, PCT. So this would be our descending limb of loop of Henle. And this is the ascending limb, right? Because the ascending one connects to the actual collecting duct. So for the countercurrent multiplier system, what's going to happen is first, salt will leave the ascending limb. So salt is sodium chloride, NaCl. So what's going to happen is there's blood. Trying to kind of draw this. Probably should have drawn this a lot bigger in hindsight. So here's my blood stream out here. So salt is going to get into the blood, right? So here's my salt entering the blood. That's step number 1. In response, water follows out the descending limb of the loop of Henle. So wherever salt goes, water is motivated to basically dilute it in order to dilute the blood. So now we have way too much salt in this blood. So water, let's draw the water in green. Water is going to then leave the opposite end and try to dilute all of that salt so it's not as concentrated. Does that make sense? So as a result, number 3, as a result, more volume of fluid is in the vessel, which raises the pressure in the vessel, right? In the blood vessel. And what do we call that? That would be increasing blood pressure. So you add more and more and more salt and water into the blood, and then that adding of the more salt and then more water raises the pressure inside of the blood vessel and raises the blood pressure. Okay, so why does salt leave the ascending limb and not the descending limb? So the reason salt will leave the ascending limb is because it is permeable to salt. So the ascending limb of the loop of Henle is permeable to salt, so that allows it to leave, and then water follows the descending limb. When I was in the class, I felt like it was really confusing. Why is it that water leaves the ascending limb, salt leaves the ascending limb, when technically the flow or the current goes this way, right? So like, how do you have salt leave first and water follow when that's not even the flow? And I'll just try to simplify it a lot, but when I got to physiology, what we learned is that the blood flows in the opposite direction. So when it says counter current, like a current at the ocean would be the water flowing in one way. So counter current means that the actual kidney is flowing in one direction, whereas the blood here is flowing in the opposite direction. So that's why it's counter current. It's also why it leaves the ascending limb of the loop of Henle first, because that's where it contacts the blood first. And then it leaves the salt leaves first, and then the water follows over here, the descending limb. That's because that would be the next place the blood comes into contact. So you don't need to know that for the test. What you need to know for the test is step number 1, salt leaves the ascending limb. Step number 2, water follows out of the descending limb to dilute it. Step number 3, the result is that blood pressure increases. So you don't need to know the part about why it's called the counter current. What I'm just telling you because when I was taking the class, I was very confused. I felt like it didn't make sense. It seemed like, okay, well, I don't really get it. Like, why is it that ascending limb salt leaves first? And that's why. It's because technically the blood is actually flowing in the opposite direction. So that is process to regulate blood pressure number 1. Okay, process to regulate blood pressure number 1. Second process, and I think we're going to have a pretty hard time getting all of this to fit on this screen, but it's the renin angiotensin aldosterone system. And I'm just going to kind of give a few highlights, and then that way we can come back to it. So that's number 2. And then number 3 is antidiuretic hormone. So renin angiotensin aldosterone system is going to involve 2, 3, 4, 5, 6, 7 steps. It's a 7-stage system. And it's going to take the juxtaglomerular apparatus. And as we've talked about, right, our goal is to increase blood pressure. So what's going to happen is there will be a drop. I'm going to try to write a synopsis and then I'll write more detail. So a drop in blood pressure triggers the release of renin from macula densa cells. Remember, those are the ones that line the bottom of the distal convoluted tubule. Renin gets into the blood with angiotensinogen, a dormant compound that's already in the blood, and they activate to form angiotensin 1. Again, this is just a summary. I'm going to write this in detail on the next slide. Then that travels to the lungs, where ACE, or angiotensin converting enzyme, is found. This is like a way for you to have it in one little screen. ACE, or angiotensin converting enzyme, will convert angiotensin 1 into angiotensin 2. So now we have angiotensin 2 going to travel to the adrenal gland. And then that will form, or that will cause the release of aldosterone, which travels to the distal convoluted tubule and collecting ducts, which causes there to be a reabsorption of salt and water, which then results in an increase of blood pressure. So what we'll talk about on the next screen is we'll actually kind of explain each of those really quickly so that it's a little less, in one spot, but that would be a good way for you to like write in your notes or on an outline so you could kind of go through them and remember them in order, which is one of the things you'll need to know, like what is the correct order. But you want to know a little more about them than just that. So we'll go over that one. And then for antidiuretic hormone, this one is also called vasopressin. Vasopressin is the other name for it. It is released by the hypophysis or the pituitary gland. So you want to know that for the test. You want to know that it's released by the hypophysis or the pituitary gland. It is a hormone, right? Antidiuretic hormone. And when it is released, triggers the cells of the distal convoluted tubule and collecting duct to install aquaporins. And aquaporins are water gates. Okay, so here's my little distal convoluted tubule, right? Here's my loop of Henle proximal convoluted tubule. So in my distal convoluted tubule and my collecting duct, here I have my blood vessel kind of sitting outside. And when I install these aquaporins, which are like water gates, all of the water sitting inside of this distal convoluted tubule will flow back into the blood. Basically, water doesn't want to leave the blood. Filtration process in the kidneys kind of forces water to do what it doesn't want to do. So if you install aquaporins allow water to flow back into the blood, which is where water wants to go. So aquaporins are pores or water gates that allow all of that water to flow back into the distal convoluted tubule and collecting ducts through that aquaporin. So to install aquaporins, water gates for water to flood the blood vessel. Okay, what is the name of that blood vessel? I'll just write it right here. This is the peritubular capillary, right? I didn't write this over here, but what would be the name of this blood vessel? The vasa recta. Remember, the vasa recta is the one around the loop of Henle, right? So the peritubular capillary would be the one involved in both the renin-angiotensin-aldosterone system and in the antidiuretic hormone system. So both of those would be peritubular. So basically, aquaporins just involve water. So in the antidiuretic hormone system, this does not involve salt. So, in countercurrent multiplier, we get salt and then water follows. Renin-angiotensin-aldosterone system, salt, and then water follows. But the last system, antidiuretic hormone, is just going to be water gates, allowing water to flood the blood vessel without salt coming first. Okay. So let's talk about our renin, angiotensin, aldosterone system. And this takes place, remember, in the juxtaglomerular apparatus. And remember, the juxtaglomerular apparatus, we saw it on the model. Here, wait, let me try to draw this in different colors here. We had our afferent arteriole, afferent arteriole, and that's the one that comes into the kidney. We have the efferent arteriole, and that's the one that leaves the kidney. Then we have all of these capillaries in between, and those are the glomerulus, right? But the glomerulus is not a part of the juxtaglomerular apparatus, it's just for filtration. The juxtaglomerular apparatus is the afferent arteriole, the efferent arteriole, and then the distal, let's do it. Here's my distal convoluted tubule with its specialized cells, which are called macula densa. So those are number 3. So the macula densa of the distal convoluted tubule. So 1, 2, and 3 together make up the juxtaglomerular apparatus. Okay. So the juxtaglomerular apparatus is for the renin-angiotensin-aldosterone system. So when we test you on it on the lab exam and we ask you, what is the juxtaglomerular apparatus, we want you to answer because we're hoping that you know, because you need to know about it for the renin-angiotensin-aldosterone system. So step number 1, a drop in blood pressure is noticed or detected by baroreceptors. Remember, baroreceptors are receptors for pressure in the distal convoluted tubule and collecting duct. So they both kind of notice that we have this drop in blood pressure. This triggers the release of renin. So when baroreceptors detect a drop in blood pressure, we release renin. Renin is an enzyme made by the macula densa. Okay, so they're going to release that enzyme. So then we go to step number 2. Already in the blood, where in the blood? This would be the peritubular capillaries, right? It's the capillaries going around the distal convoluted tubule and collecting duct. So already in the blood, in the peritubular capillaries, is a dormant compound. Dormant means it's asleep, right? As a compound that hasn't been activated. So this is inactivated. And this dormant compound is called angiotensinogen. So when renin is released, angiotensinogen and renin combine and travel to the liver. Okay, so step number 3. In the liver, that's when we get the conversion of angiotensinogen to angiotensin 1. Of angiotensinogen to angiotensin 1. Okay, so that happens in the liver. So here's our first little organ, our liver. So step number 4, angiotensin 1 goes to the lungs. Angiotensin 1 travels to the lungs, and in the lungs, my lungs always look a little interesting. There we go, kind of looks like lungs. So in the lungs, angiotensin 1 is converted to angiotensin 2, converted via ACE. Okay, ACE stands for angiotensin converting enzyme. So the lungs produce ACE. So it travels to the lungs. In the lungs, angiotensin 1 is converted to angiotensin 2 via ACE, and ACE is going to be made in the lungs. Okay, so that was our destination in the lungs. Because of angiotensin converting enzyme, we have the conversion of angiotensin 1 to angiotensin 2. Step number 5. Let's do angiotensin 2 in red. Angiotensin 2 travels to, a lot of traveling in this, travels to the adrenal gland. Remember that we have our kidney, right? Kidney. And sitting on the top of the kidney is the adrenal gland, okay? So I don't know why that kidney looks so crazy. There we go. Okay, so sitting on top of the kidney is that adrenal gland. And when that angiotensin 2 travels to the adrenal gland, I should just say it will then release aldosterone, and aldosterone is a hormone made and stored in the adrenal gland, made and stored there. So it's going to release that aldosterone into the blood. So it travels to the adrenal gland, then release aldosterone hormone made and stored there into the blood. All right, now we get the last step, number 6. Aldosterone goes all the way, aldosterone gets to the peritubular capillaries around the distal convoluted tubule and collecting duct around, I'm going to write D, CT, and CT. Okay, so it gets into that peritubular capillaries all the way around the distal convoluted tubule and collecting duct and triggers the reabsorption, let's do it in red, the reabsorption of salt first. Remember, reabsorption means it's getting back into the blood. So the reabsorption of salt first, then water follows. And what would be the result of the reabsorption of salt first and then water following? An increase in blood pressure, right? So peritubular capillaries here would cause salt to get in first.
Brooke?
Yeah.
Is this supposed to be CT4? What's the CT?
Oh, sorry. I've just got a lot of symbols going on. This is collecting duct, and this is and. But I don't know. I found out recently I don't know how to do the and symbol apparently. I think it's like that. I think I do it wrong. I think it's supposed to be the other way, but.
Okay, so, but the CT is for collecting duct.
Collecting duct, yeah. DCT, distal convoluted tubule, CT,
Okay.
collecting duct, yes.
Okay, thank you.
So that would be all of your steps. So as far as the test, what do you need to know? You need to know everything I wrote on this screen. So this would be like definitely the still the bulleted form of what you need to know. You need to know what causes the release of renin, right? Which we said is first, you get a drop in blood pressure. You need to know renin is an enzyme made by the macula densa. You would need to know that when renin gets into the blood, it activates the dormant compound angiotensinogen. Then you would want to know that they activate and travel to the liver. In the liver, that's when we get angiotensinogen with renin converted to angiotensin 1. So conversion of renin and angiotensinogen into angiotensin 1, which will then travel to the lungs where it's converted to angiotensin 2 by ACE. Angiotensin 2 causes aldosterone to be released. And then aldosterone release triggers the reabsorption of salt and water in the distal convoluted tubule and collecting duct. So you actually need to know all of this that you see on the screen. Okay. Hopefully it's kind of nice because you can see it in one place, but I don't really know how to tell you that, how to kind of make it easier for you. So going back to this screen here, this would be your 3 systems. Again, counter current multiplier happening in the loop of Henle. First salt leaving the ascending limb, then water following the descending limb, both going into the vasa recta to increase blood pressure. Renin-angiotensin-aldosterone system uses the peritubular capillaries. That increases blood pressure as well. We just talked about it. Antidiuretic hormone will use the distal convoluted tubule and collecting duct again, installing aquaporins this time with no salt involvement, just water. Also with the result of, I didn't write it over here, but obviously over here we'd be increasing blood pressure again, right? All of these increase blood pressure. Okay. All right, so definitely get really good notes on this. Keep your notes from this class. I think most people keep notes, but if you're someone who gets rid of notes, that would be really unwise to throw your anatomy notes away. You're going to want these again all the way into nursing school. A lot of medications we give act on the renin-angiotensin-aldosterone system. So you're going to want to keep your notes because you'll probably want to reference those again. So try to make good notes so that you could look back on them in a few years and know what you actually wrote down. You will reference this stuff again. All right. Any questions at all on this? Is everyone good with doing reproductive Monday? Planning on doing reproductive Monday. Is anybody wanting to do male reproductive today? Good on Monday. Okay, good. Okay, just want to make sure. So I'm planning on doing practice questions now, if that works for everybody. And then I think I'll kind of just, we'll end somewhat early. I'll leave it open to questions. And I might pause and write some more practice questions after we do the ones that I have on the module, if that works for everybody. And then if someone needs to leave early, you can, okay? All right, so I'm gonna delete these 2 screens. I think everybody's pretty much done writing, right? I didn't really, there's not a whole lot more I have on antidiuretic hormone. Let me look. Make sure I didn't miss anything. Released by the pituitary gland, causes the creation of aquaporins in the distal convoluted tubule and collecting duct, causes the water to get into the distal convoluted, get into the peritubular capillaries to increase blood pressure. Technically my notes, I only have 1 page in my notes. Wait, I can't, I only have 1 page in my notes. But a lot of the stuff that's in this is like stuff that is not like super necessary to know. Like it says the aquaporins are part of the phospholipid bilayer, but it's kind of like, I didn't say that because I feel like it's obvious, right? They should be part of the phospholipid bilayer if you're going to install a protein channel in something. And they're a protein. Aquaporins are a protein. So synthesis of the aquaporins would be ribosomes. But I don't think I don't think those will be on your test. Like the fact that it's ribosomes or in the phospholipid bilayer isn't really what the test will focus on. The test wants you to know, what is antidiuretic hormone? It's a hormone made in the posterior pituitary. Its other name is vasopressin. What does it cause? The creation of aquaporins. What do aquaporins do? They cause water to flood into the distal convoluted tubule and collecting duct into the peritubular capillaries from the distal convoluted tubule and collecting duct. Where are the aquaporins installed? On the distal convoluted tubule and collecting duct. So I think that should be everything. I think what I wrote down should be everything. If you have something else in your notes though, let me know. I didn't mean to accidentally miss something there. Okay, so these are some of the questions available to you guys on the module. So let's take a look at number 2. I think I have about 10 questions we can go over here, and then we'll go into, I'll try to write some of my own. So number 2, blood pressure receptors. What are those examples of? So it should be easy. I just said this, right? Good. Baroreceptors, right? Baroreceptors are for pressure. All right, number 3, when taste is generated, which is not involved? We can do a few census questions, why not? Good, right? So all of those would be involved. So E is the correct answer. Very good. Gustatory bud, pore, hair, and cell, all of those are involved. All right, scroll past some of these senses ones. (14) the glomerulus, which is not true. Good. So D would be the correct answer, right? Because we know that the glomerulus has fenestrae. The glomerulus filters blood. The glomerulus has an afferent arteriole leading into it, and then it does not have vasa recta, right? Vasa recta are the blood vessels that float around the loop of Henle specifically, right? Good. So there are how many types of nephron? Question 15. 1, 2, 3, 4, or E? Good. 2, right? Juxtamedullary and cortico. Question 16. The majority of filtrate is reabsorbed in good. Proximal convoluted tubule. Okay, so the proximal convoluted tubule is going to be reabsorbing 65% of that filtrate, right? So majority of that filtrate is reabsorbed in the PCT. 17, secretion happens mainly in the good. All right, if D is the correct answer, and then where is the other place secretion happens? So where is the other place secretion happens besides the distal convoluted tubule? Yep, collecting duct. Good. So the distal convoluted tubule and the collecting duct, both of those secrete. All right, question 18. The counter current multiplier system. Which of these is true about the counter current multiplier system? Good, none, right? So all of those are false. So it regulates blood pressure. It involves the vasa recta and the ascending and descending limb of the loop of Henle. All right, for question 19. ACE enzyme, which of these is true? So remember we have renin made by the macula densa, combines with angiotensinogen. Together they travel to the liver. That converts it to angiotensin 1. Then that travels to the lungs, where ACE, which is angiotensin converting enzyme, converts angiotensin 1 into angiotensin 2, right? So then angiotensin 2 travels to the adrenal gland, which releases aldosterone, which travels to the distal convoluted tubule and collecting duct for reabsorption of salt and water. So if you're looking at this question, that's why we know that C would be correct. ACE, or angiotensin converting enzyme, is made by the lungs, okay? The precursor to angiotensin 1 would be angiotensinogen, right? So A, precursor to angiotensin 1, would be angiotensinogen. There is no precursor to renin, and the ADH system just involves aquaporins. All right, 20. Aldosterone is good. Aldosterone is a hormone, right? Renin is an enzyme. Aldosterone is a hormone. Okay, I don't know if I said that. Remember to say that specifically, but aldosterone would be a hormone, right? It's made in the adrenal gland. It is made in the, let me double check just to make sure, but it's made in the cortex of the adrenal gland. So you might want to add that to your notes. I don't think I said that specifically. It could be a test question, so I don't want to. So aldosterone, this is a hormone made in the cortex of the adrenal gland. Okay, so you would want to write that down. Just get that somewhere in your notes for the fact that it's in the cortex of the adrenal gland. Because remember, there's the cortex and the medulla of the adrenal gland. All right, so 21. The macula densa are specialized cells. Which of these is not true about them? Good. They release aldosterone, right? They do not. The answer is they release aldosterone because they don't release aldosterone, right? So macula densa, they do line the bottom of distal convoluted tubule, so A would be true. They are part of the juxtaglomerular apparatus, so B would be true, and they do release renin, so C is also true. So they do not release aldosterone. Aldosterone is released from the cortex of the adrenal gland. 22, the juxtaglomerular apparatus, which is true about that?
Good. It raises blood pressure, right? So remember, the juxtaglomerular apparatus will activate or respond to a drop or a lowering in blood pressure, but ultimately what it's going to do is it's going to then raise the blood pressure. So the answer there would be raise the blood pressure, because that's the end goal of the juxtaglomerular apparatus, to raise the blood pressure. 23, which of these is not a component of urine? So remember, calcium, or A, is a part of the inorganic compounds, and the inorganic compounds are a component of urine. So A is actually a correct choice. Okay. B, C, and D you guys already knew, but A would be an inorganic. So A is actually correct. So E would be the correct answer, right? So A is a component of urine. B, C, and D are all components of urine. So we would choose E because all of the above are components of urine. Does that make sense? Calcium is part of the inorganics. 24, kidney stones. Which of these is not true about the cause of kidney stones? So this is a very tricky one. So B, I see some people answering B. Imbalanced pH is technically also a cause of kidney stones. So high minerals can cause them. So A would be correct. So A is not the correct answer. Like, it is true, it causes them. B, imbalanced pH can also cause them. Remember, it's from the crystallization or calcification of anything, including an imbalanced pH. So even an imbalanced pH could predispose you to kidney stones. Low water intake obviously will also predispose you. Crystallization is what they are. So the answer here would actually be E, or none, because all of those do predispose you to getting kidney stones. So kind of a tricky one, because imbalanced pH sort of seems like it shouldn't be right there, but it actually is. Okay, so what time is it? So it is 10. So we have kind of two options here. Let me see how many more questions you guys have available to you in the module, because that'll help me determine what I should do here. Previous. Looks like I have a lot on brain. Okay, so this is my question for you guys. Would you rather me write some questions now and go over them now, or I can write like a bunch of questions? I can like spend the next hour writing questions, and then we can go over those next week. So I'm trying to see how many questions you have. How do I figure out how to ask you guys this? How many of you have done some or all of the practice questions? Type one in the chat if you've done most of the practice questions already. Okay. Because I want to see how many people would benefit from more practice questions. So if you guys would like me to write more practice questions, what topics would you guys like me to write more practice questions on? So we have, you just follow this: 1, muscle; 3, nervous system; 5, excretory, which is like kidneys; 7, reproductive. I think no matter what, I'm going to write a lot more on kidney because it looks like there's hardly any questions on kidney. It looks like we need more on 5. 3, I think there might be a good amount. I just checked mine and I wrote more on nervous system. So do you guys want me to write, we want to write more on kidney today. So my question is, trying to figure out how to word this. Do you guys want me to write more questions today and then go over them next week? That would be option 1. So like we would just kind of end the session now. If you guys have questions, you can hang out and I'm going to write practice questions and we'll go over them next week. Option 1. Option 2, I write like 10 or 15 questions now, and then we go over them once I'm done writing them. So do you guys want option 1? We kind of end the session now. Option 2. Two would be now. I would just take a break, write some questions, and then we would come back. 1 would be we would wait until next week, but I'll write more practice questions today so you guys have more practice questions. It just takes me a while to write them, so I don't really want to like make you all wait a long time. 2, I could do like 10 questions and we can come back. We can also do both. Like I could do 10 questions, we can go over them, and then next week I can do more. Yes, next week we will go over male and female reproductive, because I don't think, have you guys watched male and female reproductive? Because technically that's assigned for next week. So most of you probably haven't seen it, which is totally fine. But like I wouldn't probably have watched it yet if it was me. So why don't we end now? You guys can go watch your male and female reproductive videos. That's what I would recommend doing today. So that you can study all of your content. And then next week, I'll go over male and female reproductive on Monday and the models. And then Thursday session, we will do practice questions and some lab stuff. So I'll do both, okay? And I'll publish the practice questions. You guys want me to publish the practice questions today when I finish them, right? Yes? Practice questions published? Yes? Okay. All right, so let's do that. I'll just write practice questions and then I'll publish them for you guys in the study resources module. So let's end here. But if you guys have questions, you're welcome to stay. I'm just going to be writing on my computer, so it doesn't take that much for me to kind of stop what I'm doing. But are we all good on what we want the questions on? I have one person wrote back muscles, kidney, and nervous system. Elena, you want to see more on that? Anybody else have feedback on what they'd like to see questions on? I don't know, probably all of you haven't done. Looks like we might need more on muscles. Because if this is all, yeah, okay, I'll do more on muscle contraction. Nervous, I'll try to find the areas where I need more on nervous. Can anybody give me any like specifics on what they want to see more on? Like more than just nervous, like do you want to see like brain specifically, or spinal cord, or autonomic nervous system, or just everything? Just try to get everything. I'll see how many I can write today. Kidney and muscle. Okay, I'll make kidney and muscle the main focus because I think there's a good amount of nervous. So I'll try to do nervous like towards the end of the questions, and I'll focus on kidney and muscle first. Okay, spinal cord and nervous, got it. Spinal cord. Okay, I'm seeing spinal cord a lot. I'll make sure I get spinal cord in there. Okay, all right, thank you guys so much for coming. I will see you Monday of next week, 4:45 to 6:45, and we'll do questions and reproductive mainly on the session. All right, see you then, thank you.
I have a question.
Mhm.
In my notes from the lecture that I watched for the counter current multiplier, he says that the concentration increases at the top. What does that mean? I think I'm confused because like stuff's leaving, so why would the concentration be going up?
Yes, so that is a great question. The answer is that you don't need to know
Okay.
about the concentration for the test. I'm just saying that because when I was taking the class, I got like very confused too. I was like, okay, what's this concentration thing? The concentration technically would be the most concentrated at the bottom of the loop of Henle, where it interacts with the blood vessel, because as more and more salt leaves the ascending limb, that's kind of how that works. But in terms of the test, I just wouldn't worry about it too much. Concentration, he said concentration was the highest at the top.
He said increased concentration at the top, and like it's really hard for me to see he's drawing in the videos because I can't see the whiteboard, but it looked like he was pointing to the very top of the ascending loop when it's going back to the distal convoluted tubule.
Yeah, that can't be what he meant to say.
Okay.
That wouldn't work because it starts there. So if it starts there, it can't be the most concentrated there, because the most concentrated is when you get to the point where no water has been added, and yet we have salt that's been added the whole way down. So that would be for the blood, because like I showed you, the blood flows in the opposite direction.
Mm-hmm.
So that would be the bottom of the ascending limb, like right when the descending limb changes over to the ascending limb. At that point, that would be where it's the most concentrated in the blood with salt, because then you get over to the descending limb side and then water starts to add. So that would be the most concentrated part. So he might have said it. I mean, I do that all the time. I say the exact opposite of what I'm trying to say, which probably was what was happening.
So when you say that like the blood is flowing in the opposite direction, is that in the capillaries that surround?
Mm-hmm. In the vascular.
It sounds, it's confusing to me.
Technically, so I try not to complicate it because I feel like it's just sometimes it's easier to keep it simple, but technically the blood flows in the exact opposite direction. So the vasa recta, which is the blood vessel, actually has a descending limb and an ascending limb as well. So you'll learn that in physio. But when you're at the ascending limb of the loop of Henle, it's actually the descending limb of the vasa recta. So it actually makes sense when you realize that the blood flows down descending limb first and then goes on the ascending limb. So the blood is really what you should be thinking about. The blood, the descending limb, is meeting up with the ascending limb of the loop of Henle. Does that make sense? So the blood gets to the ascending limb first, then it loops around and the blood gets to the descending limb last. So that's why it's like it feels like, wait, that this doesn't make sense. Why is it going the wrong way? And it's going the wrong way in terms of the loop of Henle, but it's going the right way in terms of the blood, because the blood literally does the flip side, the opposite.
Okay, that actually makes a lot more sense. And is the vasa recta, is the capillaries around the entire loop of Henle, not just the bottom? Because he made it sound like it was just the bottom, but it's the entire loop.
Yes, because there's a descending limb of the vasa recta, and then there's an ascending limb of the vasa recta. So yes, they're around the whole loop.
Okay, thank you.
Yeah.